Hello students, how are you? Today is 3rd November 2025, and when you look at it, plus or minus, we have about 3 months before the commencement of the forthcoming JAM. I have a very interesting question on the board, and this question is coming from gas laws. In chemistry, we have gas laws, we have the Charles law, we have the Boyle's law, we have the pressure law, we have the ideal gas equation, we have the Dalton's law of partial pressure, we have the Avogadro's law, we have the Graham's law of diffusion, and all of that. Now, look at this very question on the board. It says 16.8 grams of sodium hydrogen triisocarbonate 4 is completely decomposed by heat. Calculate the volume of carbon 4 oxide given off at STP. And in bracket, they gave us the mass of the individual elements contained in the sodium hydrogen triisocarbonate 4. Now, the mass of sodium is 23, that of carbon is 12, that of oxygen is 16, and that of hydrogen is 1. Also, they gave us the molar volume of any gas at STP, which is 22.4 dm³. In this question, option A is 22.40 dm³. Option B is 11.20 dm³. Option C is 2.24 dm³. And option D is 1.12 dm³. This is JAM 2008, question number 4. What do we do to this effect? The first thing to do here is solution. The first thing to do here is to write the equation of reaction. We have different types of reaction. In fact, this is a very interesting question because it's coming from gas laws, it's coming from types of reaction. It's also coming from a topic known as stoichiometry. Now, look at this. The compound here is sodium hydrogen triisocarbonate 4. That is NaA. I have equation of reaction. Equation of reaction. What would be the equation of reaction? The compound, which is sodium hydrogen triisocarbonate 4, is decomposed by heat. On heating, it will decompose. When it's being heated, what does it decompose into? It decomposes into 3 different compounds. It decomposes into sodium triisocarbonate 4, that's sodium carbonate, water with the evolution of carbon 4 oxide. So it will decompose into the product will be sodium triisocarbonate 4, that's Na2CO3, plus water, which is H2O, plus CO2, which is given off as a gas. Now in this question, we are trying to get the volume of this carbon 4 oxide gas that is liberated, that is being given off. This is a gas, this is liquid, this is aqueous sodium. Okay, in this case, it is solid because it is not dissolved in water. It is being heated to be able to decompose into this. Now, balancing the equation, because whenever an equation of reaction is written, there is every need for you to balance it. Balancing the equation, I can see that I'm having 2 atoms of sodium here, but I'm having 1 here. So I'll just simply put 2 here. That means I'm having 2 atoms of sodium, 2 atoms of sodium. I'm having 2 hydrogen. I'm having 2 hydrogen here. I'm having 2 carbon here. I'm having carbon plus another carbon, that's 2. Then I have oxygen, that's 2 times 3 atoms, that's 6. I'm having 3 here, plus 1 here, that is 4, plus 2 here, that is 6. So the equation is balanced. With this equation, you see that 2 moles of the sodium hydrogen triisocarbonate 4 liberated 1 mole of the oxygen gas, of the carbon 4 oxide gas. Since 2 moles liberated 1 mole, and they gave us the mass of the sodium hydrogen triisocarbonate 4 that was decomposed by it. What do? We can find the amount. But from the information provided in bracket, you see that we can calculate the molar mass of this particular compound. So molar mass of sodium hydrogen triisocarbonate 4 will give us sodium is 23 plus hydrogen is 1 plus carbon is 12 plus oxygen is 16, but we have 3 atoms of oxygen, that is 3 times 16. Adding on, we have 23 plus 1 plus 12 plus 3 times 16 is 48. So adding everything up now, we are going to have 23 plus 1 plus 12 plus 48. That is 84. So the molar mass here becomes 84 grams. 84 grams per mole. That's the molar mass. Now, remember that the amount of substance, that is the number of moles of a substance, which is written as small letter m. The number of moles of any substance is the reactive mass divided by the molar mass, where the small letter m is the reactive mass and the capital letter M is the molar mass. Now, what is the reactive mass of this compound? It is 16.8 grams. So the amount of substance here becomes, the number of moles of this compound becomes the reactive mass 16.8 divided by the molar mass, that is 84. This will simply give us 16.8 divided by 84. That is 0.2. So the number of moles of the compound which was decomposed is 0.2 moles. Now, remember that from the equation of reaction, 2 moles of sodium hydrogen triisocarbonate 4 produced 1 mole of the carbon 4 oxide which was given off. Therefore, I can say if 2 moles of sodium hydrogen triisocarbonate 4 produced 1 mole of carbon 4 oxide, then 0.1 mole of sodium hydrogen triisocarbonate 4, then 0.2 mole of sodium hydrogen triisocarbonate 4 will produce what of carbon 4 oxide. That is, from the equation of reaction, when 2 moles of sodium hydrogen triisocarbonate 4 produce 1 mole of carbon 4 oxide, what will 0.2 moles produce? What do I do? I will simply cross multiply. X times 2 gives us 2x equal to 1 times 0.2 gives us 0.2. Therefore, x will become 0.2 divided by 2, which will give me 0.2 divided by 2. That is 0.1, which is equal to 0.1 mole of carbon 4 oxide. That is 0.2 mole of sodium hydrogen triisocarbonate 4 will produce 0.1 mole of carbon 4 oxide. Now, but recall that according to the question, that 1 mole of any gas at STP, the molar volume of any gas at STP is 22.4 dmq. Then I can say that 1 mole of which carbon 4 oxide is part of the gas now. 1 mole of carbon 4 oxide is 22.4 dmq. So if 1 mole of carbon 4 oxide is 22.4 dmq, what will 0.1 mole of carbon 4 oxide be? Then 0.1 mole of carbon 4 oxide will be x. Cross multiplying again, I'm having x times 1, that is x equal to 0.1 times 22.4. 0.1 times 22.4. 0.1 times 22.4 times 22.4. This will give me 2.24, which is equal to 2.24 dmq. Right, which become our answer. So 2.24 dmq of CO2, that's carbon 4 oxide, was liberated at STP. We'll go to the option and see which is the correct answer, which is option C. Option C is our correct answer. These are the type of questions you tend to be seeing in chemistry. And when students see this type of question, they tend to shy away from it. And it's very, very easy. The reason why the solution took this long is because I'm trying to teach you. Normally, when I'm solving this question, it's not going to take me up to 60 seconds to be able to get the answer. And the more you give yourself to it, the better it becomes, the better you'll be able to solve. Thank you.